Mair either walks, cycles, travels by car or travels by bus to work every day. Her method of travel each day is independent of her method of travel on any other day. So independent means it doesn't affect. The previous day doesn't affect what she does the following day. The tables below shows the probability for 3 of her methods of travel on any randomly chosen day. Walking, biking is 0.5, car is 0.1, bus is 0.25. Calculate the probability that on any randomly chosen day she walks to work. So we want to find this value here. Probability always adds up to 1. So the first thing I would do is add these up. Because 0.1 is only one decimal place, I got to put a 0 in to make it to 2 decimal places. 5 add 5 add 0 is 10, 0 down, carry the 1. 1 add 1 is 2, 4, 8. I got a 0 in the front. And then 1 take away 0.80 or 0.8. 0 take away 0, you can't use 0. 0 take away 8 you can't do, so I need to borrow 1. 10 take away 8 is 2. 0 take away 0 is 0. So 0.20. Calculate that on the probability that on any randomly chosen day she walks to work. So 0.20 or 0.2. What is the probability that on any randomly chosen day she either travelled to work by car is 0.1, or bus is 0.25. So I need to add these together because it's or, because I got the 2 chances. So 0.1, I'll put a 0 on the end. 0 add 5 is 5, 1 add 2 is 3, so the answer to that is 0.35. What is the probability that in any randomly chosen week Mair travel to work by car on the Monday and by bus? So and means times, because you need the car and the bus the following day. So car is 0.1, bus is 0.25, and then, right, 1 times 25 is 25. But we got 1, 2, 3 numbers after the decimal point, so I need to put a 0 in front of it. So it's 0.025. Sean states when a fair coin is tossed and a fair dice is thrown, the probability of getting a head and an even number is half. Is she correct? You must show enough workings to justify your answer. Let's do this into a table. Okay, so if I've got my coin, an even number on my coin or an odd. Let's have a look. I'll do the coin up here, and I'm going to do the coin with a head and a tail, and then I'm going to be having my numbers on my dice, which is 1, 2, 3, 4, 5, and 6. I could have just done that with odd or even if I wanted to. So let's have a look. This means I got a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5. A head and a 6. This one means tail and a 1, tail and a 2, tail and a 3, tail and a 4, tail and a 5, tail and a 6. So from this, head and an even number. That's head and even, that's head and even, that's head and even. So the chance of getting a head and an even is 3 out of 12. Or, because 3 goes into 12 4 times, it's a quarter. So Sean is wrong. Right, it's 1/4. Like the previous question, okay, probability adds up to 1, and we want to work out the probability of getting the fruit juice. So I'm going to line up my numbers, 0.5, 0.18, 0.27, and because this is no number on the end, I'm going to make a 0 there. 0 add 8 add 7 is 15, 5 down, carry the 1. 1, 2, 3, 4, 9, add 0, and then 1 take away 0.95 is going to be 0.05. What is the probability that on a randomly chosen day he has either tea or mineral water? So O means add, so tea is 0.18, mineral water is 0.27, 0.18 plus 0.27 is 0.45. What is the probability that in any randomly chosen week Alan has coffee on the Tuesday and tea on the Friday? This one you means times, okay? And means times. So it's 0.5 times the t, which is 0.18. 0.5 is the same as a half. A half of 18 is 9. So the answer to that would be 0.09. Or you could have done 5 18s and 90. Wrote it down as 90. There's 1, 2, 3 numbers after the decimal point. So I have to put a 0 in front of it. So 0.090, which is the same as that. Next question. Circle a correct answer for each of the following statements. Helen has bought one of the 80 tickets sold in a raffle. The probability she wins the top prize is. She's bought 1 out of 80. So 1 out of 80 is a fraction. Would be this one. One ball is selected at random from a box containing 5 blue balls, 4 red balls and 1 yellow ball. The probability that the selected ball is blue is. Right, 5 of them are blue and there's 10 in total, so it's 5 out of 10. I can cancel that down because they divide by 5. 5 goes into 5 once, 5 goes into 10 twice, so it's a half. A bag contains some red, green and black beads. One bead is selected at random from the bag. The probability of selecting a green bead is 1 out of 3. Which of the following sets of beads could have been in the bag? So they're telling me the green is 1 out of 3, so a third of them are green. So in this one, the probability of getting the green would be 1 out of 4 because there's 4 beads. This one, the probability of getting green is 6 green out of 12, which cancelled down to 1 over 2 because 6 goes into 12 twice. This one is 3 green out of 3, 6, 10. That doesn't cancel down. 4 green out of 4, 11, 12. 4 goes into 12 3 times. So it's this one here, because that's 1 out of 3 when you cancel it down. A fair 6-sided dice and a fair coin are thrown together once. Circle a correct answer for each of the following statements. The number of possible outcomes is, I showed you earlier on the sample space diagram, because you could have a head and a tail on your dice, on your coin, but then you could have a 1, a 2, a 3, a 4, a 5 and a 6. So you could have a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, a head and a 6. And similarly you could have a tail and a 1, a tail and a 2, a tail and a 3, a tail and a 4, a tail and a 5, a tail and a 6. So the number of possible outcomes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The probability of getting a 4 on a dice and a tail on the coin is this one. So it's only one chance of that, so it's 1 out of 12. The probability of getting a multiple of 3. Multiple of 3 is a 3 or 6, and a head on the coin. So I got a head and a 3, a head and a 6. So I got 2 chances out of 12, which cancels down to 1 out of 6.